Hello, everyone. My name is Pavlo Lutzig, and I represent the Division of Cancer Epigenomics at DKFZ in Heidelberg and Department of Oncology at KU Leuven. Today, I want to speak about democratizing access to scientific workflows with WorkflUX. Our work is motivated by a well-established notion of a reproducibility crisis in biomedical research. So among 1,600 researchers surveyed by Nature in 2016, almost 80% agreed that there is some kind of reproducibility crisis, and almost half considered to be significant. Since then, the situation didn't improve significantly. So among the reasons which the researchers named as underlying this crisis, many have something to do with data analysis, including low statistical power, not enough replication, unavailability of methods, code, and data, as well as lack of technical expertise for reproduction. So to give you a context, I want to introduce our work at DKFZ within the Division of Cancer Epigenomics, where I've been leading a computational group since 2019. One of our tasks was to enable continuous support of epigenomic data lifecycle. And the division consisted of 30 to 40 researchers, among which 5 to 7 were bioinformaticians under my supervision. And we dealt with large and rapidly expanding set of data types, including whole genome bisulfite sequencing for DNA methylation, ETIC sequencing for chromatin accessibility, ChIP-seq, and several other alternative protocols for chromatin analysis. So when we started establishing the data analysis infrastructure, we looked and surveyed the possibilities, and at these well-known pages, we found dozens and dozens of different frameworks, engines, systems, and so on. So it was very difficult to orient ourselves. Nonetheless, in the recent years, there are several market leaders, including NextFlow, SnakeMake, and 2 initiatives which aim to describe the workflows independent of their of the implementation of the workflow management systems, including workflow description language, WDL, and the common workflow language. I will not go into detail describing the advantages of common workflow language. So what attracted us was its open and extensible specification concept, a truly community-driven project. Again, it's independence of specific implementation, and this gave us a lot of flexibility with respect to computational infrastructure at DKFZ. And I think the most important advantage was explicit, exhaustive, and typed description of inputs and outputs for all the steps and for sub-workflows and workflows, which in my opinion is one of the strongest advantages and enables the developers to build upon CWL, and I hope I can give you an example of that in this talk. So using CWL, we created workflows for all major types of data we worked with, including whole genome bisulfite sequencing, ETIC sequencing, ChIP sequencing, and further protocols for chromatin analysis. All these workflows are available from our GitHub organization, CompEpigen. So the next problem we faced when we tried to deploy these workflows and made them available to our division, and I think the situation is very similar in many other research groups, big or small. So we have experimentalists who generate the data and are the most interested party in obtaining the results. So we were the workflow developers, and we create the logics of data analysis and make it available through one of the languages, be it CWL or anything else. Of course, there is a HPC infrastructure maintained by specialized engineers at the level of organizations and institutions. So what we noticed, there is a considerable barrier for the experimentalists to apply workflows, simply because most of the steps involve command line interfaces. So like deployment of the workflow management system, deployment of workflows and dependencies, configuration of the jobs, execution in heterogeneous environments, even accessing results, especially large scale analysis results, large files, monitoring the analysis and reporting results, everything we call provenance. In the workflow world, this often includes command line interfaces. And yeah, as we know, in biomedicine, the clinicians and biological researchers, they are not always familiar with the command line, although the situation is improving rapidly. So at that time, there were already alternatives, including Galaxy project. So it was already quite popular back then when we started working on this software. However, when we examined the possibility to use Galaxy within our division, we found several things not working, including the significant administration overhead for installing and maintaining a Galaxy instance. It's a concept which makes it suitable for large user bases, organizations, and communities, but yeah, it's often an overkill for small groups. And it's Galaxy has a sort of Swiss knife philosophy. All possibilities are already either pre-configured or can be added. Yeah, and sometimes this is again too much. At that time, there was no easy and reproducible configuration of bad jobs, and we'll come back to it and to our solution. Again, the main focus of Galaxy was not workflows, but single tools. And yeah, concerning the workflows, there was own workflow ecosystem and no support of popular workflow languages, although it has now changed with the addition of CWL support very recently. So Kersten Breuer, who was a student in my group, an enthusiast of workflows, he designed and implemented a solution which we initially called CWLab and later renamed to WorkflUX. So it's essentially a graphical framework which hides all the complexity of workflow deployment, execution, and monitoring, and accessing the results under the hood, and makes it workflow experience very comfortable for the experimentalists. So this is the democratization in essence, because now not only the computer geeks, let's say, can perform the complex analysis, but also everybody who knows the data and knows how to use WorkflUX. So this is how WorkflUX looks. So it's a very simplistic web interface. Yeah, there's just a landing page and 3 tabs for different tasks, and I will go through each task of the task in detail. So first, a bit of an architectural outline and an overview of the features. So WorkflUX allows the users to import common workflow language workflows from many sources, including public repositories, but also like locally from single files. So in the front end, they're imported, and in the same time, the backend processes the workflow, and based on the workflow structure solely, creates a parameter form, either HTML or Excel, or open Office spreadsheets or open document format. And for the spreadsheets, it creates templates. And this way, the user configures the jobs, and the backend generates CWL job files in YAML or JSON, and they are sent to the execution API. So we have a highly configurable execution API, which allows you to connect to essentially any type of CWL supporting infrastructure, be it local execution with a reference implementation CWL tool, or HPC cluster setup, for example, with Toil, or cloud-based setup with Cromwell, you name it. And yeah, everything is extremely lightweight, easy to set up and adapt to concrete needs of the users. So the first step is the import. So there are many options such as public URL, including GitHub. So this is extremely convenient. You just copy a GitHub URL in raw format and you have the workflow imported. But also other options exist, including tool and workflow repository services. Next, for the job configuration, so all the input parameters are analyzed, and according to a type, either an HTML input created, or you get a properly configured template for your spreadsheet. So through the spreadsheets, it's possible to configure batch jobs, so it runs from many samples. So the jobs are automatically validated. The input files are automatically searched for on connected storage. And all the built-in documentation from CWL doc tags is transferred to the tooltips in the HTML form. So once the jobs are configured, you can execute them using a minimalistic running interface. So you can select an execution profile, which describes the connection to the computing infrastructure, and you of course can select the load, so how many job runs will be started in parallel and so on. And there is of course a possibility to stop the job, reset it, delete it, and so on. Finally, each job comes with possibilities to monitor it completely and report the results. So first of all, to enable the provenance of parameters, so you have the actual CWL input file displayed in the respective tab. There's also dynamically refreshed execution logs and an interface to access the output files. They can be downloaded directly or as an archive of the complete output directory. So a few technical details. The front end of WorkflUX is based on React. And it's a single page web app. And through Ajax, it communicates with a Flask-based backend. All the data can be saved in a relational database, either SQLite, MySQL, anything else, any database of your preference. And there are layers to organize things for each user. Yeah, all the workflows and jobs are registered. So execution profile is essentially a structured text file, and it allows you to send a job via Python, Bash, PowerShell interface. And except for execution step itself, there is a possibility to add pre and post processing scripts job evaluation, and cleanup download scripts. And the deployment of WorkflUX is very simple, either through virtual environments, as a Python package, or a Docker container. So we have tested WorkflUX intensively within a context of interdisciplinary research groups with us and our collaborators, and works very nicely. So it can be used locally as a desktop application with HPCs in clusters, and in protected clouds and other types of infrastructure. And this is all requiring minimal setup. So we are expanding it towards like larger organizational scale. So trying to integrate GA4GH standards for workflow execution, data access, and multi-user, multi-project management, execution on publicly available infrastructure, and enabling collaborative work on protected data. So we also think of adding support for further workflow languages, including WDL, which will probably easier due to similar concepts behind, but also SnakeMake and Nextflow, which do not have such clear-cut interfaces, which would enable automated configuration and creation of spreadsheets or HTML forms. I want to integrate deeper with the initiatives around the European scientific cloud and resources, so be state-of-the-art in that respect. We want to provide images for major commercial cloud providers, such as Google, Microsoft, or Amazon clouds. And we want to link to large data resources, biomedical databases, object storage, and so on. So if you like this concept, try WorkflUX out. It's available freely under Apache 2.0 license from the WorkflUX organizations. And we, of course, welcome feedback and all contributions. Thanks so much for your attention. I'm happy to answer your questions in the Q&A. Bye.